Recording. Today I'm doing spiral matrix. It's a very irritating problem. Given an m into n matrix, return all elements of the matrix in spiral order. So like this, we start from 1, 1, 2, 3, 6, 9, 8, 7, 4, 5. It's a very simple problem. You just have to simulate this. Well, for some problems, the best way to really come with, yeah, basically you need to simulate what the problem asks us to do. Okay, let's try to simulate this. Well, I will need a while loop. Let's keep it true. Okay. And let's define my final list result new array list, and I'm gonna say as long as size of this list is smaller than matrix length and is matrix column dot length. So as long as size is smaller than total element in my matrix, I want to okay, so we first need to move from left to right. Okay. Okay. Left, right, up and down. So let's see. For int I is my I is at I want to go to the right, so it should start from 0 from left, while I is smaller than right, I plus plus. Okay, int left is 0 and right is what right side 0 1 0 1 2. I think it's right. My right should represent this a vertical wall, right side. So yeah, n. Okay. Left plus plus. No. Matrix at result dot add. Okay, let's just test it till here. Break. Okay, first 3 elements, fine. Now let's simulate the downward movement. Okay. We are at 3. 3 is already in my list. So my J should start from right to down. Right is at and here. So I wanna add 1 to my right. While J, this is J. While J is less than, what is this? Down. Down. Zero, 1, 2, 2, 2, 2, and 2. Hang on. So 0, 0, 0, 0, 1, 0, 2, 0, 2. We are at 0, 2, and then to move down to 1, 2, 2, 2. 1, 2, and 2, 2. G plus plus. Result dot add matrix. This time I wanna modify the row, and this should stay the same, right? Okay, let's define my down. Well, it should represent this so vertical line, so n, right? I'm just thinking about that because J is also, maybe this loop will not run. Let's try. Yep, this loop didn't run. Okay, well, what's wrong? While J is smaller or equal to down, that would give me an error. Some kind of error. 0. Because right and down have same value. What should I do here? Like, should I do something? Maybe I should do something like this. Come on, come on, come on, come on. Left, right. Can I use my I from here? Is it's still at 0, 1, 2. It's still at 2. Okay, it's 2, 0, 1. It's the same thing. No. Zero. 0, 1, 1. What is still 0? Well, we have int up, right, left to right, right to down, right to down. So my right, I think my right should still be 0. My right should be 0. Because I need 0 here, or 0 plus 1. So whatever is 0 down, can I keep my down to 0? But no, down is, we are going to down. We are going down. Okay, okay, okay. 0. Well, my left is still 0, right? Six. Okay. 6, 6, 6. Okay, this is what I wanted. Now from down to 0, from down to left, I is greater than left, I minus result dot add matrix here I need changing my row should say same. I need changing column. Okay. Three. What? Down? Value of down is well within bounds. System dot out dot print I. 3. I is 3. Why? Three. I'm not sure what's the value of down. Three. Even after subtracting one. Why? That's why I said this problem is frustrating. But yeah, after this loop, we only need one more loop, and hopefully, hopefully I'll not have made plethora of mistakes. So like 2. So I need offset by 2. No, I don't need to offset. No, I need to offset down. Six, 5, no. No. I wanted 9. I wanted 9. Six, no. Yeah, sure. This way we get. Maybe I need to change these variables here, but I didn't do that last time. Down. Down should be here. Zero, 1, 2. Shouldn't it be n? Or maybe I was looking at the wrong example. Yes, oh god. Yeah. Okay, 9 8. Yeah, pretty good, pretty good. Yeah, of course, because it's m by n matrix, m into n. Okay, last final loop, final loop. Not this one. Now I want to move from down. No, because we are already down. From left, right, up should start at down. Shouldn't down have started at 0 as its initial position from down? Um, from left to right, from right to down. Maybe this is the right thing to do here. So from left to right, from right to down. What is right? Down is 0. So here. It's getting harder to keep track of this. My right was 0. No, right wasn't 0. Right is here. This is a wall that right represents. Down is here. Then why is it 0? This point. Well, then what should it be then if not 0? I don't know. 3. Okay, man, just 5 more minutes. I'm giving up. 0. 0, 1, 2. So our right is 2 here, and 2, 1 next. Because right is 2, this point, I can say that I want to move my. Well, that's wrong. I'm just not. I think my down is not deserves. My down should not be 0, or else I could make it to iterate reverse in reverse, reverse, reverse. Ouch. What's the current output? Yeah, sure. Q. Because this loop is not running, second loop is not running. I want it to go from right to down, from no, from right, from up to down, right, from up to down, of course. Yes, I think I got it. But in that case, my up should be, and my down should be an m. M is 1 n minus 1. Let's see. Up. Nine eight. No. Not acceptable. Not acceptable at all. For some reason, I think this loop did not run. Because, well, left to right, up to down, up to down. Let's just keep it to 0 for now. 0, 1, 2. Right and up. Okay, who is causing trouble here? Is it up or down? Is it up or down, or is it okay? No one in particular. This right and n minus 1 should be j. Hmm. 1, 2, 3, 4. You're kidding me. You're kidding me. What is j at this point? Oh, you mean j? No, this should not be my up. Well, I want the row value to be changing. I want a constant. I want the constant column value, and it cannot be up because up is 0. But I can use up, but I cannot use up. I have to use j as in the column because it's changing. No, I want a changing rows too. So stupid. What am I doing? What am I doing? Okay, we are way above our time limit. Let's see. Let's just give up. Up 0, right is m. Hang on. What is n? Okay. Well, j is up, while j down minus 1. Right. Down. Right. But I was getting the outer bound. J 1 j smaller than or is equal to down minus 1 or equal to down minus 1 minus 1. 6, 9, 8. Oh god, this is working, this is working, this is working. Just had to take some help. That's fine. Let's just copy this. And now I want to move from left to right, right to down, no, left to right, up to down, right right to left. Should change this to, or let's just read the solution. Left to right, up to down, right to left, left to right, up to down, right to left, and down to up. Okay. 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 I lose. What is the time complexity of this solution? Um. Well, the space complexity is constant. You're not making use of any extra. No, this array, output array. And the time complexity is also m into n. We are visiting each element in the matrix exactly once, even though we have I mean, we have so many loops, but it's still a linear solution, right? Let's just verify. Yes, m into n. Can I can I actually say this is a linear solution? Okay. Can I say time complexity is linear? Yes, absolutely. It's linear. Every element is visited exactly once. Every element of matrix is visited exactly once. The loop together covers all rows and columns without repetition. No nested traversal beyond. Okay, let me just take a look at this. Um, for every J loop, we are decrementing one from here, decrementing one here. Hmm. Moving on, next greater element 1. The next greater element of some element x in an array is the first greater element that is to the right of the x in the same array. You are given two distinct zero index arrays, num1 and num2, and num1 is the subset of num2. Okay. Determine the next greater element of. If there is no next greater, then the answer of the, okay. We are given two arrays where the first array is the subset of the second array. So this num1 is the subset of this, and we just need to return this array output containing the next greater element of each element in num2. What? The next greater element for each value in num2. Okay. What is greater than 4 in this array? Nothing. What is greater than 1? What is the next greater element? Okay, what is the element? Okay, which number in num2 is greater than 1? 3, right? So we just add 3 to my, okay, we add 3 to our output array. Okay, which number in num2 is greater than 2 after the 2? Okay, the next. Okay, first we need to locate the element in the num2 and then find greater than greater number. Okay, for example 2, let's locate 2 in this array. Oh, here this is. Okay, moving on, we'll now look at 3. Is 3 greater than 2? Oh, yes, so let's say 3. Now 4, let's locate 4 in this one. 4 is at the last index, and well, this is the array ending, so there cannot be any. In fact, I think the last element is always, the last number is always -1 in my output. Can you find in, this is a monotonic stack? Yes. Can I do it in linear time? Yes, I mean we can okay, let's try to use a monotonic stack. How would we use brute force here? How can we use brute force? We can well, we can do it with two loops, two nested loops, right? And using two loops, it's very easy. We can we use a hash map? I think for even with hash map, the squared complexity With hash map, it's also quite complexity because we need to locate this thing first. Okay, how? What is a monotonic stack? Hmm. 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 Well, I know the pattern, uh, but which array should I use for adding element for pushing elements onto my stack? This one? Okay, let's see. Let's try to do it without a stack. I'm gonna need a hash map and I'm gonna need a for each number in num1 I need to find a greater number than num after num in num2. Hmm. New hash map for num in nums1 now dot put num -1. Now the map uh, if 4 um, how does stack come into play? Monitoring a stack is really for let's say this is my stack. Okay, I put 1 onto my stack. Now I look 3. Is 3 greater than is 3 greater than my is 3 greater than the element at the top? Yes. So we pop that element in at 3. Right? This is how we do it, right? So if 1 was at the top and 3 is greater than 1, so we'll just pop off a monotonic stack is a stack of elements in decreasing order. I think, can I just have some picture? Monotonic stack is a special stack that maintains its element in either strictly increasing or decreasing order. Enforces a ordering constraint when function it removes any element that violates the okay. So do we want elements in increasing order or decreasing order? Why would I need while is smaller than nums dot length for boolean start looking false. For each number in nums2, if my map contains that number, start looking is true. And I can just say start looking and start looking is true, and num is greater than look, then look is what? Look is that number, and at the end just if look is not equal to no, this is not a good idea. Not a good idea. Actually, I need a loop here from this point. It's not a very good way to do this. No. No. I still can't find the significance of monotonic stack, but I know it's important. Especially all this is garbage. Delete. can I have my hash map basically? So I have these numbers as my keys, and I want to find spawning is a stack of just increasing or decreasing order. So increasing order or decreasing order, elements in increasing order or decreasing order. So it can be just like this, right? Or this, right? Can I then how can I use it? We want the greater element. So if 4 is at the top, 4 is in my map, then there is no greater element than 4. Similarly, but if I keep if the list is sorted like this, then if I come across 4, if I come across 1, so I pop off 1, 1 being the smallest element, and I can check, okay, is there a 1 in my map? Yes. Since I've already popped off 1, I can put this current top as value of 1 in my map. Okay, then I pop off the next element. 2 is is 2 is 2 present in my map? Yes. Okay, so map 2 with whatever is at the top in the map. 3. But no, we messed up the order. We have messed up the order. This is not how it works. Okay, let's look at the solution. Num equal found, greater found. For j, well, this is a nested. For each element in j, if j and num are same, well, we found the equal. If equal found and j is greater than num, no, this This doesn't use any stack. What brute force it? Just give me the working of, show me the working of a stack. Complexity is n squared. Okay. I thought we could do it in linear time. If m is greater than top element stack, then it is the next stack dot add. If stack is not empty, it's greater than egg. Map dot put stack dot pop. All right. So we are creating a map. So let's say this is my array. Oops, where'd that go? No, not this one. Yeah. 1, 3, 4, and 2, and we are mapping each number to its greater. Mapping into if so here we have an 1 goes to stack, 1 goes into stack, and then it's 3 is done. We'll check. Okay, is 3 greater than 1? Yes. Then map 1 to 3. Mapped 1 2 3. Okay, what's the next? And 3 goes to the stack. Okay, what's the next? 4. Is 4 greater than 3? Yes, then map 3 to 4. What's the next? 4. Is 4 greater than, what's at the top? 3? 3 is at the top now. Is 4 greater than 3? No. 4 is not greater. No. Is 3 greater than 4? Hang on. I'm just getting confused here. Let's just look at the stack or map. Print map. Okay, there are only two numbers in this array. Whose greater element exists. So okay. Okay. What is the complexity? N plus M. Space complexity is M for stack and map. Right. And I guess we are done for today. Uh, hmm, it's not that difficult problem. Yeah, of course it's marked easy, but still wasn't very difficult. If you know, of course, if you know how to use monotonic stack. Okay. Thank you for watching this video.